This question, a plane on a runway takes 16.2 seconds over a distance of 1,200 meters to take off from 0 initial speed. Assuming constant acceleration during takeoff, calculate the speed on leaving the ground in part A and the acceleration during takeoff in part B. So if we note down the information that we've been given, we know that the time over which the acceleration happens is 16.2 seconds. The displacement is 1,200 meters, and it starts from an initial 0 speed, so the value of u is equal to 0. We're asked to find its speed on leaving the ground, so we want to find in the first part v, the final velocity. If we look at the 4 quantities that we have, the equation that we want to use is s is equal to u plus v over 2 times t. Generally works best in physics if we do all our rearranging before we put our numbers in. So if I rearrange this equation for v, I'm going to get 2s over t minus u is equal to v. And so then I can do my calculation. For A level, there is always a mark for showing the numbers in the calculation. So this is a worthwhile line of working to write down. 2 times 1,200 over 16.2 minus 0. When we do that, I think we get an answer of 148 meters per second. Part B, the acceleration during the takeoff. When we come to do this, the answer that we got in the first part of the question here, I think the safe decision to make at this stage is to think to yourself, maybe I got the value of v wrong. So the ideal way to find the value of A is to go back to your original data that you were given and find the other equation involving A. So in this particular case, that's S is equal to UT plus a half AT squared. I'm going to rearrange this equation for U. So I get S minus UT is equal to half AT squared, and therefore A is equal to 2s minus ut over t squared. Take as many lines of algebra to do this as you need. There's nothing wrong with taking a few more lines if it helps you get to the right one in the end. So we're going to find our value. Again, marks for putting the numbers in. So that is 1,200. Sorry, 2 times 1,200 minus 0 divided by 16.2 squared. And this gives us a value of 9.14 meters per second squared. In the question, the last check we might make is whether we've been sensible with significant figures. We've got this value, which is clearly written to 3 significant figures. This value, very difficult to tell. It could be to 2, it could be to 3, it could be to 4. Let's assume the person who wrote the question was careful with significant figures and all the values are to 3. So our 2 answers also given to 3 significant figures. We don't have to write 3 significant figures in brackets because we can see that this is 3 significant figures.